People in Europe first used tidal energy to operate grain mills more than 1,000 years ago. Incoming tidewater was retained in storage ponds, and the outgoing tidal movement was used to turn water wheels to mill grain. This process of using falling water and spinning turbines to create electricity was introduced in the 19th century. A large tidal barrage was built in Rance, France in 1966, and still operates today with 240 megawatts of electricity generation capacity, the largest in the world until 2011, when an array with 254 megawatts capacity opened in South Korea. Marine energy technologies, including tidal and river current technologies, transform the energy in the natural flow of oceans and rivers into clean electricity. Tidal energy systems harness power from the movement of water created by the moon's gravitational force, while river current energy systems capture power from the directional flow of water in a river, using specially engineered generators. In suitable locations, tidal energy can be converted into useful forms of power, including electricity. In the past 2 decades, the industry has turned toward in-stream tidal energy generation, where a single device or groups, or arrays, of devices are placed within the tidal stream. The European Marine Energy Centre, established in 2003, is the world's largest facility for testing and demonstrating wave and tidal technologies in real sea conditions. The facility, which has grid-connected test sites for larger prototypes and scale test sites for smaller devices, has facilitated the testing of more tidal energy devices than any other site in the world. Because water is denser than air, tidal energy is more powerful than wind energy, producing exponentially more power at the same turbine diameter and rotor speed. Tidal power is also more predictable and consistent than wind or solar energy, both of which are intermittent and less predictable. This makes tidal energy an intriguing renewable energy source to pursue. The challenge is making it commercially feasible to capture and convert the energy into usable power at scale, as well as finding uses of tidal energy where costs are less sensitive than national grid electricity. Two of the world's largest tidal power stations are barrages in South Korea and France, with 254 megawatts and 240 megawatts electricity generation capacity, respectively. The next largest in Canada has a much lower generation capacity at 20 megawatts. There are other technology deployments at various stages in countries including Scotland, France, Japan, Korea, China, Canada, and the United States as developers bring forward new and improved tidal current technologies that show promise for clearing key hurdles to commercial viability. The ability to assess the performance and environmental effects of new technologies in real sea conditions is critical to sustainable industry advancement. Tidal and river current resources in the United States are equivalent to 7.8% of all U.S. power generation in 2019. Even if only a portion of these resources are captured, they could provide local, affordable, and clean power to rural and remote island communities and help achieve the Biden-Harris administration's goal of a net-zero emissions economy by 2050. The U.S. tidal and river current energy industry requires long-term and substantial funding to move from testing devices one at a time to establish a commercial site. The complexity of installing devices and navigating permitting processes, combined with a lack of connection to local power grids, have proven to be a consistent barrier to advancing tidal and river current energy. Tidal energy technologies have been slow to develop, and some industry participants have exited the market. Suitable locations for tidal energy facilities are inherently limited, given that not all coastal bays and tidal channels experience the conditions required for effective power generation. And among those limited locations, some are not near the grid, requiring further investment to install lengthy undersea cables for transmitting generated electricity. Achieving cost reductions, developing devices that can endure ocean forces, and minimizing environmental effects to improve tidal energy's commercial viability is and must be the primary focus of research investments in this area.